Hi, everyone, and thank you for joining. This is our 13th meetup, and we have Ionut with us. He prepared a presentation about how to create more gas cost efficient smart contracts or smart contract clones, that is, clones that are more efficient to create and to call. Okay, so Ionut, whenever you are ready, I'll stop sharing my screen and you can share yours.
Sure. Thank you, Alex. I'll go right away.
Cool.
Just 1 second. Yes. Can you see it?
Yep.
Yes.
Okay, cool. Yes, so I'll be talking about this kind of design pattern called clones with immutable args. I have this remix open with the code. Here is the repository that you can look at the code. So it's this person who is very active in the community. They developed this clones with immutable args library, and inside you can see basically the boilerplate files. And then just a sec. Yes, you can see the clone with immutable args library, which is their library, then a clone file, which you're supposed to inherit, and then an example clone factory. So I'm going to just describe what these are. We'll probably start directly from the proxy and what it is and why you would need these clones with immutable args, and then build up from there. So in the proxy pattern, basically one caveat that you have is you want to have your contract upgradable. So you have an implementation, and then you have your proxy contract, which points to the implementation, and then it uses this EVM opcode called delegate call. What that does is it runs the implementation's code in the context of the proxy. So for example, yeah, that's basically what it does. So whenever you interact with the implementation, in order to interact with the storage, you need to go through the proxy all the time. But if you go directly to the implementation, you're not going to have the same storage which you have worked with previously. So now, one caveat to that is you cannot use constructors with proxies and implementations. And I'm going to just write a simple example here. So if you have like a contract proxy like this, and it has an implementation, and then you have like your fallback function, which delegates to this code. So you have something like this, delegate call to implementation. And now you have your implementation contract, which has a constructor and a uint265 variable called v. So in the constructor, you might want to, you have a parameter, and you assign it at construction time. So if you use the proxy pattern and you plan on using the proxy pattern with this implementation contract, the constructor will not work. The reason it will not work is because the constructor sets a variable inside the storage of the implementation. But when you work through a proxy, you want to store this value inside the proxy's implementation. So that's why you would use something called an initializer, which is you would have a separate function. Let's just call it initialize. Initialize, yes. I'm not going to put like all the Solidity syntax. And in here, you would have also uint256v, and you would set v to v. The reason why this is different is because you can call the initialize function through the proxy. So you would call the initialize function through proxy.fallback, and in this way you would actually work with the proxy's storage. Does that make sense so far?
Yes,
Yep.
I have a question. For the implementation smart contract, I think I think it's stored on the implementation because the constructor is in the bytes of the code when you deploy it. Is it right? So
Yes.
when you deploy the implementation, you deploy the constructor that then it's deleted from the bytecode, if I'm right.
Yes, it's deleted afterwards, and only the runtime code remains. But
Okay.
everything that happens in the deployment is inside the implementation storage.
Exactly, and that's why actually you can't use a constructor, right?
Yeah, the constructor is kind of a special function which only runs at deployment. So when you deploy the implementation, the constructor will run, it will update the implementation's storage, and then it will get thrown out. It will no longer be on the blockchain, but even if it was, I don't think it would be callable through the proxy.
Okay, thank you.
Okay, yeah, so if it's clear so far, this is why the constructor would not work. Now comes a question, could I do something like this? Like imagine if V was a constant or an immutable variable, and I'm again working in this proxy implementation pattern, and let's say V doesn't need to be configurable. I just know what I want the value to be. And I would have my implementation be something like this. You want 256 constant V equals 5. Would this work? So what would I see if I'm calling proxy dot, let's say V through the fallback? Would it be 0 or would it be 5 in this case?
It probably it would be 0 because the constant is on the implementation bytecode.
I think the storage and the implementation and the proxy don't have the same storage order.
Yeah.
And it's override.
Yeah, let's sorry, my bad with that. Let's just say here you have an implementation as well, just so that they don't overlap. So we just discard this to not have to mess with storage layout. Just saying that I'm setting this V at the time of construction to a constant. And can I see this from the proxy storage? Like what would this function call return?
I think 0.
That would be the intuitive answer, but it would actually return 5. And this is because it's like a gas optimization that people do sometimes. And the way this works is when you have constant or immutable values, they get saved to the
in the bytecode of the contract.
Yes, they get initialized and saved in the contract bytecode, not inside the storage. So in this case, V equals 5 is kind of like an abstraction of solidity, but underneath in the bytecode, you would have this hard-coded value somewhere. So through the proxy, because you are working with the code of the implementation, you are actually able to see that the V is 5. So in this case, this would work. And you would correctly see that it's 5. And now the question comes, is everything clear so far?
Yes.
Okay, perfect. So now the question comes, how can I put, note that this also works with immutable. So even if I had something like this, and then I'd have a constructor, and I'd say V equals 5, a proxy.v would still return 5, just because the immutable value also gets stored inside the bytecode. So now comes the question, how can I make it so that I can use this constant or immutable variable from the proxy, but this immutable variable is parameterizable. So basically, let's assume the implementation is actually like an ERC20 or something like that. And I just have and this is like a clone contract. So this is a proxy that is going to point to the ERC20. and I can just deploy multiple of these clones. Let's say each one of us wants to have an ERC20. So I cannot set like a specific value here. I need to somehow let the user pick the name of their ERC20, like this. So now the question becomes pretty complicated. Like, how can I deploy this clone and not have to mess with it a lot, but also be able to set immutable storage or immutable variables and save on gas that way? Inside, and these immutable variables would be kind of like parameters. Like I could choose one name, Alex could choose another name. The reason why this is a bit complicated is because I can't use an initializer function. So if I call an initializer function on my proxy, I will set the variables to whatever I want, but it's impossible that they would be constant or immutable, because constant and immutable only works at deployment time. So this is kind of like the clones with immutable. This is what the clones with immutable arguments pattern solves. It allows you to deploy a clone that points to an implementation. And when you deploy that clone, you can specify some arguments specific to that implementation, which are going to be immutable or constant. And it does that using some assembly magic, basically. Is that clear so far?
Yes.
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 Okay, perfect. Let me just look through my, yes. And now let's take a look through the code a bit to see how it does that. So the main idea is this. I'm just gonna have some other small note here. You have your clone factory, which creates clones. This is clone 1, and then this is clone 2, and then this is clone 3. And they all point to an ERC20 implementation, which is the same ERC20 implementation. But inside clone 1, you have name 1. Inside clone 2, you have name 2. And inside clone 3, you have name 3. And these are immutable, and you save gas this way. So how does the clone with immutable arguments work? At a very high level, what it does is that the clone factory deploys a clone which in its bytecode has the immutable parameters saved at the end. So just as you would have, for example, for a smart contract, the bytecode, when you deploy, the layout is creation code plus runtime code plus some, I guess, constructor arguments. Yeah, and this is it. So basically, when the clone factory is going to deploy something, it's going to deploy creation code plus runtime code plus immutable arguments. And the clones are written in such a way that whenever you go through the fallback, it not only delegates calls to the implementation with the message.data that you intended, the call data, but it also loads its own code into memory, gets the last part of the code, which is the immutable arguments, and puts them at the end. So the clone actually forwards execution to the implementation and passes the immutable arguments as call data. So inside the implementation, you're going to see them as call data. Inside the proxy, you took it from the bytecode, which is just like you would access like a constant or immutable variable. It's actually like an immutable variable at the core. Does that make sense so far?
Yep.
Okay, so now we can just look a bit through the code. So here is the clone. This is from the GitHub library. And it has like these specific parameters. So in our case, the clone would be would be what the ERC20 would inherit. So it would be the implementation, basically. It has kind of a confusing name, but our ERC20 would be is clone. So this is not the proxy, this is the implementation actually. And it has all these functions to be able to load arguments from the end of the call data. Let me just, yes. So all these functions get uint8 from arguments, get uint64, get uint256 array, and get uint256 and address. Use this get immutable args offset function. So what does the immutable args offset function do? It actually have some notes on it, on this URL stuff. So it gets the call data size, it subtracts 2 from it because the last 2 bytes are reserved to store the length of the immutable arguments in all these clones with immutable arguments pattern. So then it shifts it, and basically what it does is it goes to the end of the call data. From the last 2 bytes, it figures out how big the immutable arguments are, and then it jumps back by that length. So it arrives right at the end of the message.data that was supposed to be, and right at the beginning of the immutable arguments. I also had, yes, okay. So now this function, if you imagine the call data is going to be something like this. Function selector plus function arguments plus immutable arguments plus 2 byte length of immutable arguments. And the get immutable args offset basically gives us this point. So from here to the right. And you can see you can specify an offset to this function. So basically what you would say, let's say in your immutable arguments, you know that the first one is supposed to be an address. So you'd call get arg address with offset 0. It's the relative offset 0 added to the absolute offset of starting from immutable arguments. Now, if you know your second argument is uint256, you would call get arg uint256 with argument offset 20. Because you know the first thing in the immutable argument is an address that is 20 bytes. You need to jump to the right of it. And this is what is shown in the example clone as well. So this is taken from the repository. And here it just shows like how you would use such a contract. This contract has 4 parameters, which are supposed to be immutable, but it's hard to do in this proxy pattern. So first one is an address you would get from offset 0. Second one is a uint256. You add 0 plus address, which is 20, and you get the 256 from offset 20. Third one is uint64. So you add address plus 0, or you just 20 plus uint256, which is 30 bytes. So it starts from 32 bytes, 52 bytes, sorry. And this is 8 bytes. So you need to go from the 60th byte. Does that make sense so far?
Yes.
Yes.
Yeah, it does.
Okay, cool. And now I just wanted to give a little bit of detail on how the deployment actually happens. So you also have these 2 classes, which is clones with immutable args, which is part of the library, and then an example of a clone factory. And you can see how to deploy such clone with immutable args. So basically, you know for your contract that you're going to have 4 immutable parameters. You encode pack them together, and then to the library you specify, I want to deploy this implementation, like a proxy that points to this implementation, and with these immutable arguments. And then the clone with immutable args library is going to take care of the rest. And this just exemplifies you have many options to deploy, which is create two, and then add all the types of creates, basically deterministic and all that solidity stuff. And now in the clone with immutable args, it's a lot of assembly stuff. But maybe some more important parts are, for example, the clone function. If you look at what it does, it takes the implementation that is supposed to point to, it takes the data that we said, and it takes a message.value. It's a parameter to the create function in assembly. And then it does this get creation bytecode function. So this is the bytecode of the proxy or of the clone that is going to be deployed. And yes, let's just take a look inside it, because it has a couple of interesting parts. So this function is going to return to us the bytecode that is going to be deployed as a clone. And if you look through it, there are several important parts. Let's see. Okay, so as you can see, data is the immutable arguments, and the extra length is 2. It also tells us 2 bytes for telling how much data there is to be appended to the call. So the length of the immutable arguments, basically. And then it does some computation, how big should be the creation size, how big is the run size. This is like just some hard-coded numbers, because the creator of the library just wrote down this very optimized way of deploying a clone like this. So he knows exactly that the creation size is going to be 10 bytes, and these are the 10 bytes that is going to be. And then the runtime size is going to be 55 bytes plus the immutable arguments, and this is the 55 bytes that it's going to be. So maybe just some implementation detail here, just to see a bit how it was written. I thought it would be interesting to present where the delegate call happens and how the immutable arguments are loaded from the clone's bytecode and put inside the call data, because that's kind of like the most interesting part. Yes. Okay, and this is actually the chunk that is responsible to it. So all this assembly here, what it does, this is the important part, the code copy. So what the code copy does, when you have, this is the stack, you have the I think this is the call data size, 0x37. This is a hard-coded value because of how all the bytes are set up. And then these are like the length of your extra immutable arguments. So what it does is it puts in memory from the beginning. Yes. So inside the bytecode of the proxy, the immutable arguments will start at the 37th byte in hexadecimal, which 37 is like 55. If you remember correctly, the runtime had 55 bytes. So exactly after the runtime code is going to be the immutable arguments, as we said. So that's what's going to be copied to memory. So this chunk goes to the 55th byte in the bytecode of the clone and gets all the bytes of the immutable arguments and puts it inside memory. So after this is done, some other steps happen, and then at some point it delegate calls, and the argument to delegate call is not only the call data, but also the arguments that are loaded from memory. And this is how this happens under the hood. Now, this method is actually one of 2 or 3 methods that can be. There is another article, and I can share this with the group after the presentation about some more or less optimal ways to implement clone with immutable args. And these 2 are some very good examples. So here, This is an article about how people started thinking about it, going from the least optimal approach to the most optimal approach. And then this page does a comparison in gas. So it actually compares the method that I presented, which is append to call data, and another method, which is the implementation loads the code of the proxy using ETHCluj copy and gets the immutable parameters from there. So that's in practice, that's actually sometimes more efficient depending on how many immutable arguments you have. Is everything clear so far?
Yes, I do have a question. It's I'm not sure I'm understanding where is happening the gas optimization. So, for example, if we have ERC20 that have a function that called the total supply, like the optimization is how it happens in simple terms. So we have when we create the clone, it pass through the bytecode. It passed the immutable arg that it will be wrote on the clone, right?
Yes. So
Or
the optimization is if you have like an ERC20 with a total supply, which you can make constant, you could just do
okay.
the first thing that we did, which was total supply equals 10, let's say. And then you have UN256 total supply constant, or sorry, immutable. So this would be like the most optimal gas way to store the total supply. Where clones with immutable arguments comes in is because of the fact that you can't do this in a way in which you can configure the total supply. So that if you want to deploy an ERC20, a clone of an ERC20 where total supply is not 10, you'd have to change the implementation code because there's no way to give this as a parameter.
Okay. So that's why you have to send it as call data.
Yes. The clone with immutable arguments does exactly kind of what happens here, but makes everything to be able to specify as a parameter.
Okay. And after the deployment, is it optimized in any way, or it's just like normal clones after the deployment?
Yes, after the deployment is just like normal clones. You interact with the proxy just as you interacted before. It's just that the arguments that would have been immutable or constant inside the implementation are actually in the proxy's bytecode and are loaded automatically when you delegate call. So if you had this assembly written in Solidity, it would be a function which is more complicated than your usual fallback function of a proxy, just because it looks at the bytecode and it loads the last parts and it adds them to the call data. So it does these things.
Okay, so it doesn't increase the gas in.
It does, but probably by a very small amount, because code copy is not very expensive, and then you need to just append these to the call data at the end.
Okay.
It shouldn't increase the gas more than just having like a constant variable, because just normal constant variables, those are also stored inside the contract's code. So when you access a constant variable, it's probably loading the code somehow as well, and knows where the offset is to get that value from.
Okay, thank you.
Okay, cool. Thank you for the questions. I wanted to present one more thing, which is just a vulnerability that can come with this when you use this pattern. And the vulnerability goes something like this. I'm going to use another example file. The vulnerability kind of is in the sense that the arguments are immutable only if you call them through the proxy. So the proxy has like some hard-coded values inside the bytecode, which is going to forward to the implementation. But if you call the implementation directly, it's still going to load the parameters from the end of the call data. But you can specify any parameters you want. You're not going through the proxy anymore. So what can happen is you have your clone, and then you have your implementation. And I'm just going to write a simple implementation contract. And this is going to have just a function x like this. And it's going to load, just as we've seen before, get arg address of 0. So we have like this implementation where the immutable variable is just one address. So I get the immutable variable. Yes. So when I'm calling this through the proxy, this is always going to be the same thing because it's taken from the proxy's bytecode and loaded it and sent in the call data through the delegate call. But if I'm calling the implementation directly, I can specify here anything I want because the get arg address looks at the call data at the end and gets the last 20 bytes or yeah, the last 20 bytes, more or less. So if my implementation by some reason does a further delegate call, let's say I have this pattern where I'm cloning an implementation, which is actually like a beacon proxy. And now I would do something like x.delegate call, blah, blah, blah. This is very dangerous because a malicious person would call the implementation directly and put the address of a malicious contract at the end. The implementation would delegate call to that malicious contract, and that malicious contract would self-destruct, therefore self-destructing the implementation. Because of the delegate call, we are inside the context of the implementation, so it will destroy all the proxies that point to it. Does that make sense?
Yes. So
And it can also affect the logic of whatever the implementation is. So it's not just...
probably need to
Katalin, go ahead.
Yeah, sorry, I have a bad network. So probably you have to write a require, right, to go to the proxy each time inside of the functions.
I'm not sure. I haven't thought of a mitigation, but maybe just like the safest thing would be don't delegate call to anything that is specified by anyone other than the proxy. So maybe you could do it in a way that the implementation figures out if it's called by the proxy or not and require that. If not, you could just think of another design where you're not delegate calling to something from the outside. And you actually store this X value in another way. And that's probably how it would be safest, but don't quote me on that.
Sorry, my internet is very bad. So I think if you solve the problem with who can call the functions, then you will solve the problem with what you can do in the functions, right? So if you are going through the proxy, it's okay to have a delegate call inside the implementation, right?
I think so, yes. I haven't thought very deeply about it, but at a first glance, maybe the require would work. Yeah.
Mm-hmm. I've deployed smart contracts with this type of require inside of each functions, and as I saw, this is the only solution that people are using right now to mitigate this problem.
Yeah, I think I've seen it somewhere as well. I just didn't think very much about the mitigation, but yeah, I think I've seen this as well in some source code.
Okay, and I have one more question, if it's okay. If I'm using the immutable args on the proxy, like on the storage, would be a uh, would be the same gas cost for immutable for this type of clones with immutable args that are immutable args on the clones, and that proxy contract that have immutable args directly on it.
I see. So you mean in your clone, you would here specify the immutable arg one,
Yeah, all of them.
immutable arg. Okay. The gas cost is probably going to be the same, maybe even slightly lower, but this approach comes with several disadvantages, which are in the clones with immutable arguments, you don't need to alter the clone at all, regardless of what you deploy. That's one of the advantages, because in the clone factory, here is where you actually specify which immutable parameters you are encoding, and it's like a very simple interface to it. The clone code remains exactly the same, just the way you call the create clone function is different. So the way you mentioned would be, it might be actually a bit gas cheaper, but it would come with the cost that it would be harder to change between other implementations. Depending on which arguments you're going to need, you're going to have to alter the proxy code.
Okay. And I'm thinking on the way the diamond proxy is working with that type of structure. If you know about the diamond storage, I think actually at that point, no, in the diamond storage you can't use immutable args. So no, it's not a good approach what I'm saying.
By diamond storage, you mean the namespace storage, where you put values at certain random locations in
Yeah,
storage.
exactly. In a struct. You use a struct
Okay,
for
yeah.
storage.
Yeah, I haven't thought about it, but I'm not sure if that would work in this case. But also that would be like a very complicated architecture. Like the diamond proxy is already very complicated. I think if you add this on top, it's just going to be very hard to debug. Maybe it's better to just leave it non-optimal.
Yeah, definitely. Just I try to challenge you and all the guys from here to think of the most optimized version. Just as concept, no one wanna get there down at assembly point.
Yeah, if you want and are curious as well, you can go through the clone with immutable args library. It has here all the bytecode that the proxy has. And this is actually pretty good insight into the minimal proxy pattern as well, because there you also have like the simplest, smallest code possible written in assembly to have like a working proxy. And it's pretty interesting how it works. But I try to present the most important parts, which is how the delegate call happens and how the data is taken from the bytecode and added to the call data.
Thank you for info.
Yeah, thank you as well for listening and asking all the questions. I don't have anything else for the presentation. So if maybe there are other questions, or if not, this was everything.
I have a question regarding maybe you know what's like the most often looked up use case for the clones with immutable arguments.
Yeah, I think probably I don't know for sure, but people usually use clones regarding vaults or Gnosis safes or things like this. So where you have like some kind of vault or multi-sig architecture that you want to deploy, and there's one implementation and you clone it. So if you wanted to make that a bit cheaper, I think it would, like the clones with immutable args would pretty much apply to anything that the clones apply to. The only caveat is because of the way these immutable arguments are transferred in the call data, you couldn't just take like multi-sig and deploy it with the clones with immutable args. You'd have to change the implementation to fit this pattern, just like we saw in the example clone. You would have to implement these functions where the immutable parameters are taken from the call data. But otherwise, you should be able to use it just with the most used use case in the clones world as well.
Right. Understood. Thank you.
Great.
I do have one more question. So, yeah. So, if you can you do a combination between clone with immutable args and minimal proxy, comic info? It's not working. Can you hear me? Can you hear
Barely.
me?
I didn't understand the second part. Could you repeat the whole question?
Sorry. No, it's better the internet. So I was, and the ones that are the simple clones, with the minimal kind of hold some storage on the proxy and also what can be immutable directly. Sorry.
Katalin, can you, if you hear me, can you write the question into the chat, please? It would be, you're breaking up. And
Okay.
if you can write it in the chat, please. Thanks.
Okay, so the question is if you can use a combination between clones with immutable args and normal clones. You probably could, but I don't really see what the use case would be, because in the clones with immutable args, you have the whole clone functionality already. So if you use clones with immutable args for one of your implementation contracts, it would make sense you use it for all your clones, basically, and there's no need to mix them. Oh, I see what you mean. So you mean, could you use clones with immutable args pattern and also on the implementation store some constant variable which is common for all the clones? Is that the question?
Yes.
Okay. I'm not let me think about it. Yeah, probably you should be able to do that because the immutable arguments inside the proxy would be stored at the end of the proxy's bytecode, and then the constant variables inside the implementation would be stored at the end of the implementation's bytecode. So if you had immutable arguments that could be different between each proxy, those would be in the clones with immutable arguments part. And then if you had some argument which would be common for all the proxies and constant, that would sit as a constant or immutable inside the implementation. This is just my first thought, but probably test it in Forge or something first just to make sure.
Okay, this was what I'm thinking too. So I wanted to validate my idea. Thank you.
Cool. Great question. Yeah.
Okay, so if there are no more other questions, or are there any questions? Okay, then. Ionut, thanks a lot for the presentation. You explained very, very clearly, and thanks a lot for answering all the questions and the different hypothetical situations. It was interesting to follow. Everyone, thanks for joining and thanks for asking questions. And see you at the our next meetup.
Yeah, thank you as well, and thanks for having me.
Thank you.